A smooth light pulley is connected by a light inextensible string passing over a smooth light fixed pulley of scale pan weight 1 Newton. Alright, the scale pan weighs 1 Newton, but the weight that's on it is 2 Newtons. So overall, just treat it as 3 Newtons. Is that okay? 3 Newtons going downwards. Is that right? 3 Newtons. Do you know what I'm finding really tough at the moment is converting. It's already in. You don't have to multiply by gravity. Why not? It's already marked as a force, isn't it? If you divide 3 by 9.8, you'll find out what mass is put on it. So if you do 3 divided by 9.8, it's essentially a 0.3 kilogram mass in total. Okay, so you don't have to worry too much about that. Alright, so essentially do not use G because it's already done. Is that alright? Now, what about this guy here? Does this guy have any weight? Where does it say that? Does it say anything about this? What does light pulley usually mean? Its weight is negligible. Basically ridiculously close to 0 in comparison. So that doesn't matter. Right? Now, what else do we have here? What do you reckon about this system in isolation? What about this system in isolation? What do you reckon? Alright, so you happy with A and A? Is that alright? Overall, this is going to go. How do you know it's going downwards? Yeah, now it doesn't support all 12 newtons, you know that, don't you? All 12, it's in motion, so nothing is fully supported. What happened if you got it completely wrong? You get a negative answer where you're expecting a positive answer and you realise it's gone in the opposite direction. Okay, we're all good. Now, it's called kinetic particles for a reason, because it's what's connected to it determines its motion. Call that T. Pick another letter for this. We go X for the tension upwards of the next part. Is that alright? Or T1 even. We use T1. There's going to be a lot of them, so I'll go for T subscript 1. Alright. Where's the easy marks? Sorry? Alright. Now, we usually use MA equals F, don't we? What's the problem here? It's in newtons, isn't it? It's really annoying that it's in newtons, okay? So how do I convert newtons back into kilograms? 9 divided by 9.8. What is 9 divided by 9.8? Anybody know?
45 over 49.
What?
45 over 49.
Yeah, 45 over 49A equals, because that's the mass of that particle. So we're currently working on this. And is it going downwards or upwards overall? We actually don't know. Because here's the issue as well. I can't do that in isolation. Why? Because it's B and it's A. So what's its overall? What's the overall acceleration? A plus B downwards. Okay? And what does that equal? What force causes it to go downwards? 9 newtons. Take away T. 9 newtons going downwards, T going upwards. We all okay with that? Right.
Would you not put 9 over G because you need G in the answer?
Does it say G in the answer? Perfect. So instead of using 45 over 49, you're just going to use 9 over G. That's perfect, Killian. Good job. Good spot. Right. What about the next one for 3 newtons? What about the next one for 3 newtons? It's going to be 3 divided by what? G, to find its mass, times its acceleration. What's its acceleration? A minus B or B minus A. What's the difference? Let's do A minus B. A minus B is assuming upwards beats downwards. So you need to lead with the upwards force. What's the upwards force? T. What's the downwards force? 3 newtons. Cross multiply up to G. And we get 3A minus 3B equals TG minus 3G. Is that okay? And what about over here? 9A plus 9B equals 9G minus TG. Is that right? If we add the two of them together, we can sort of eliminate something there, can't we? What? We eliminate the TG, can't we? Don't know if that's any use yet. I don't think it will be. So I'm going to move on to the last one. What's the last one? Huh? Okay. So what do you reckon? T1 going. So it's overall is it going down or up? It's going up. Okay. So what's it going to be? 3 over G equals what?
The acceleration is G over 2. It says here,
Oh, just the actual acceleration of the scale pan is G over 2. Excellent. Right. So that means that MA equals T1 minus what, lads? T1 minus what? 3. Okay. Just stick with me for 1 minute longer. It gets really easy now. Right? MA is what? It's 3 over G, because we're treating that all as one thing. What's its acceleration you told me a second ago? Alright, then what can we say about T1? We actually have it here, don't we? 3 over 2 plus 3 is, anybody? 4.5 newtons. But what happens to these formulas down here now that we know what B is? We all know what B is now, don't we? What is B? G over 2. And what is G over 2? Shh. Close that for a sec, will you? What is G over 2? Actually, sorry, I should leave it in terms of G. So B is G over 2, isn't it? What about here? G over 2. Right, and now we're very close to achieving what should we do with both equations now? Remember we said it wouldn't work earlier, but I think it's definitely going to work now. Stack them up on top of each other and do what? Take them away from each other. Mom, so you take them away from each other? The TG's cancel, don't they? What's left over here? 6G. 3A plus 9A. 3G over 2 plus 9G over 2. 6G over 2, which is 3G. 12A equals A equals G over 4. Let's find out. G over 4, excellent. 1 second. And we're going to wrap this up really quickly now, right? You're essentially on an elevator, okay? There's a 1 Newton mass, there's a 2 Newton mass on a scale, okay? So everybody see the 2 Newton mass? That goes downwards. Everybody cool with that? This is very important. Find the normal reaction between the particle and the scale pan. What's forcing this upwards? Not T. It's not connected by the rope. It's connected by being placed on a surface. So it's the reaction force R is causing that to go upwards. That cool, you guys? Now, 2 newtons going downwards. Is that alright? Next thing. Is this accelerating upwards or downwards? Do we find out? Up with what value? G over 2. And what is G over 2? It's 4.9. Its acceleration is 4.9 meters per second squared, alright? Really quickly. F equals ma. What is its force again? Sorry, just have to realise I'm about to put everything in terms of G again, so that was really annoying. G over 2. Okay with that? What's A? What's your mass? 2 divided by G. Alright, what's your force? R going upwards. Take away what? 2 newtons going downwards. This is important, so you should study this again. And what happens here? 2 divided by 2? Bring over the 2. 3 newtons. 3 newtons. Happy days. That was worth 35 marks that year. Ouch. And we got it done in 11.